Hi there, welcome to episode 2 of the Rust Corner. I'm joined by a fantastic guest today and someone that I've known personally for quite some time. I'll let him introduce himself shortly. But yeah, today's episode, we're focusing on a few different things, but the adoption of Rust obviously being one. I want to continue that conversation. But Max is quite passionate about talking all things testing, which, to be honest, I've never in my 4 years of working Rust stuff really been questioned around how we go about doing that and the process behind that. It's obviously a very new topic in the space, but I'm sure Max will kind of chat through that shortly. And yeah, I'll ask him the kind of classic questions I asked in the previous episodes with Eugen around kind of where does he go to learn, what would he do differently next time if you would start again, and we'll kind of dive into that a little bit as well. But anyway, I'll stop waffling. Thanks so much for joining me, Max. Would you care to just kind of introduce yourself and your journey to where we're at now, I suppose?
Yeah, so I'm Maxwell Flitton. I'm a software engineer at SurrealDB, which is built in Rust. I'm also the author of Rust and Web Programming, the PAC-T book, another author of Fusing Python with Rust, and currently writing the O'Reilly book for async Rust. And then kind of built Rust systems, built some medical simulation software that was kind of widely used by the German government, and that was all built in Rust, in Kubernetes and microservices. So quite a few years now developing Rust. It's quite fun. Yeah, that's essentially me, right? And we met at sort of initially it was a SurrealDB kind of like thing, social, and then we also met at Rust conference as well, the London one, right?
A few times now, yeah. Also, I'll put the links to your books and whatnot in the kind of episodes link at the bottom.
Yeah, I'm just.
Oh, it just kind of froze a little bit there on my side. But anyway, hopefully that doesn't happen during the recording. But yeah, we'll put those links in the description. We'll add some things in there. But yeah, we've met a few times. It's been a pleasure. And yeah, I really wanted to kind of have a chat with you because we've had, I don't know, hundreds of conversations over the last year or so about everything really. And you're, I suppose, my go-to guy in understanding what's going on in the space and yeah, bouncing ideas off of you. So I appreciate your time today. But I suppose let's start with where did you find Rust initially? Like, how did you kind of stumble upon it, and why did you decide, hey, this is something for me to adopt, this is something for me to add to my stack?
So I initially came from Python. That was my background. Did some stuff in financial tech, AI, quite a few things there. Did a lot of stuff in like big data, and I was just progressing. So I had this belief that if you are a software engineer, you shouldn't try and learn everything straight away, but you should have a scripting language. You should understand some Bash. You should understand Docker. That's pretty crucial nowadays. And you should understand kind of like that lower level language that's compiled, that's a faster, but obviously, you've got to use the right tool for the right job, right? So the analogy is kind of like if you're a builder, if you just learn how to use a screwdriver, be pretty weird if you just walk around with a screwdriver constantly trying to use it and everything. So I started looking around for my systems language, and initially, like, I thought C++ because that's very, traditional. It's kind of used everywhere. I also looked at Golang, but I was just kind of like, if I'm going to dedicate some time to it, I figured I may as well just properly research it. Then I came across Rust, and Rust had the memory safety about the garbage collection, and it was years ago now, and I just thought, this is going to smash it. And yeah, it's popularity just keeps rising. Everyone's loving it. And in terms of the ergonomics of coding and also the package management and stuff like this, I'm so happy that I picked it compared to something like C++ or Golang. And it doesn't mean that obviously systems are doomed if they pick those languages. And I'm pretty happy that people use them, but for me, it was the right choice. Right?
Cool.
So yeah, that's how I got onto it. So I started like, kind of reading around the core documentation. It was quite a while back, so I had to like look at like the core code, started to build things, and I realized that there just wasn't really anything out there in terms of like tutorials or documentation or guides, and that's how I ended up falling into the book, because like it was the lockdown, and I figured like I'm not really doing anything in my spare time, so I figured I may as well write a book. So I wrote the Rust in my programming book, because I kind of did a lot of Rust for web servers, and I figured I was in this weird, unique advantage where like there's a lot of hobbyists who try with Rust, but like when you kind of have to do something for a proper project, and I kind of had my own business with a friend, and we chose to build the system in Rust, you have to do all the boring parts as well. So instead of just doing your toy projects, it's like, well, this server has to talk to another server. Now it has to have this requirement because that's what's needed, and then you're forced to do all the boring stuff and see the system grow and, feel some pain and stuff like this. So that, really put me in a unique position where, the average Rust developer at that time, was really kind of just doing hobby stuff.
Mm-hmm.
And I was, doing all the, scaling it and deploying it live and having to like reduce the server sizes and all this sort of thing. So it was a trial of pain, really, but it is definitely worth it. And that's how I ended up here, right?
Yeah. I mean, it's still, I think right now it's still somewhat quite hobbyist in some pockets. And I think for most people, it's how do we make that transition from hobbyist or personal time development to the real world? And I think it's taken years. I mean, I've done this for 4 years now. It's taken years to even really get to a point now where Rust can be used properly in full-time employment, right? And you can actually get paid for it, which is crazy. Like back then, the idea of that was quite ludicrous, but here we are years later, and we can actually do this properly, which is great. And I'm hoping, and well, the trends have shown over the last couple of years that there are more and more jobs year on year being created, and there are more companies taking on Rust as a language. And I would like to hope that eventually we can start actually taking on hobbyists a lot more seriously into these companies, instead of having to show your, I don't know, professional experience, which is really difficult to find, right? It's the classic chicken and egg. I need experience for the job, but how do I find it? And I can't, join anywhere. So I think we're going to start seeing it more and more. It certainly has been a lot more popular, which is great. But it's interesting to hear your journey of how to get, to that side. Maybe we don't suggest everyone to write a book on it. I don't think that's everyone's journey, but certainly being able to go down that path is looking more promising now. But yeah, anyway. Okay, so with that in mind, then obviously one of the key topics you wanted to chat through was testing in Rust. Like I said at the beginning of this pod, I don't actually have any material on this myself, and I've never really had a discussion around this. So it's really, really interesting, because obviously like testing is super, super important, and in other languages and in other kind of, even in the recruitment sense, when I actually recruit for other jobs or have done in the past, it was always very prevalent in terms of, hey, yeah, we're not going to bring this developer on because they just don't have the right testing procedures, or they don't have the right kind of ideology behind it. How would you test for that now? Test for testing, how would you kind of go about, right, do they have the right kind of mindset in Rust specifically, because it's quite difficult, I imagine?
Yeah, I mean, I think before we go into that, it's really important to really discuss what testing is. Unit testing is essentially, and why it's really important, and why it separates like hobbyists from like really professional systems. So as your system grows, so if you build like a toy web app and it has like 2 endpoints and does something very simple, you build a calculator, you don't have to really do any sort of unit testing. I mean, it's nice, but you kind of know what the inputs and outputs are. The logic is very basic, and you can just manually test it, right? It takes you like 2 minutes to spin up the app, and then you do some manual testing. You're like, okay, great. And that's why, hobbyist coding usually is very different to like full-on professional systems, because when your system grows, manually testing something just becomes crazy, right? You'll never really get all the edge points and all the edge cases and so on. So let's say you've got a system where you've got like 5 servers and they all have very complex interactions, and you've got a system where you've got to add this new feature, and it's really in the core of the system. And let's say you have to have users before, and these users like have to, in a database, and then they have to make requests to a certain thing to get that feature, and use it. Now, if you're developing that means you have to manually spin that up every time. The database corruption, the set state of the database might, you'd have to get it to that state, and then you'd have to test your thing, and you'd have to shut it down, then you'd have to spin it back up again, and all this sort of stuff. It'd take forever. And as the system grows, you see that just gets more and more arduous. So when you get into these massive systems, your development will just completely slow down. So what you do is you build these things called unit tests, where it isolates the code, it creates like some sort of fake data that goes into that area of the code, and then you run it, and then you do some assertions. And we call them like mocks. There's certain ways you can do it, and there's all different ideologies around this. But then that means that you can like test your tiny piece of code without having to run the whole system. So that means that you make a slight error, you just run the test again. You make a slight error, or you make a slight iteration in your code and you run the test again. So you can see it's just so much quicker in that sense. But it also means that you can test a load of edge cases. Because you're mocking, or you're creating fake data, you can say like, what happens if my code, if the user is blocked? Okay, what happens if the code, if the user has no longer renewed their subscription, or something like this? Instead of creating that database and then filling in all the things and getting to that point of thing where you are in the code, you can just change the mock slightly. So your testing of your edge cases is much quicker as well. And then it also acts as kind of like documentation. So because you've got these different types of data and it's all mocked, and then you've got these assertions, another developer can come in and say, oh, if I put this data in, this is what happens with this little bit of code, this module that you've created, or something like this. So that's where it becomes pretty essential, and sadly that's why I think is a huge hurdle, right, in Rust adoption at the minute, is that you see a lot of like, this is how you build a web server, this is how you implement traits, async Rust, that's really cool, but I haven't really seen anything kind of like test-driven development or design patterns. And big systems where they have a load of engineers all working on small pieces of the code, this becomes like quite crucial.
Yeah.
And if anyone's interested, if you just Google David Farley, so he built core like high frequency trading systems in London. He does a YouTube channel. He openly talks about unit testing and how it's pretty much essential. He's like programming language agnostic. He talks about the concepts opposed to, but this sort of stuff like is super crucial in that sense, right?
Yeah, cool. Yeah, I've heard the name. He's like the godfather of development. I feel like I've heard his name, even like you say. I think he's quite language agnostic, because I heard a lot of talk about him during my Java days when I did a bit of recruitment there. We worked with quite a few, like you said, high frequency trading systems that spoke about him, and I think we used to prep people on watching a couple of his videos or understanding what he's been writing on. So it's funny that translates across over to our side now in the Rust world, which is quite cool. But yeah.
Yeah, he's really good. I read his book, Modern Software Engineering, and again, it's programming agnostic, and it's very high level, which I really like. So non-technical people can also read it, and he'll go through studies like, if you add more developers to a team, it doesn't actually translate to just more productivity. And he talks about how continuous integration that helps the system, how unit testing is essential, that sort of stuff. So yeah, I think Rust really needs to adopt like more material on unit testing. I was speaking to some people speaking to a developer at Discord. He contacted me, and he was talking about like how they're also trying to figure out unit testing. So I sent him some of the code that I've worked on, because I've managed to get in Attic Web, I've managed to get unit testing 100% across the board, from the async and accepting and the API, or to the individual, to the unit testing of the async functions, to unit testing of the database connections. But I had to write my own macros. It was not easy. And then I also had to put async functions in boxes, which reduces the performance to make it testable, which is kind of mad. But I mean, to people who are not Rust developers, Rust is still more performant than, let's say, Python or something. So don't use that as a disqualifier. But even if you put the features in boxes, but it's finding the time, right? There's a chicken egg situation, as you say. There's a lot of really enthusiastic hobbyists who they want to do cool stuff, so they don't do stuff like end-to-end unit testing in their spare time because it's not really the most exciting thing.
Mm-hmm.
And then the few people who are in professional Rust development systems were so stretched, in terms of O'Reilly contacted me for the async book and stuff. Like I can't write a unit testing book as well as writing the third edition of the web programming and the Rust. So it's just not enough time, right? So we need to find more people who are in professional roles, I guess, who can start to share their unit testing approaches.
Is there no I don't know, forum or subreddit even for any of this? Like that's something that maybe we can actually get built out and get some conversations happening, I suppose. No?
I mean, yeah, that would be really cool if we actually built a community. I mean, at risk of sounding elitist, of people who are professionally employed in Rust, and it's not just so they can get together and say, "Oh, look how cool we are." It's more like sharing their actual approaches to how they solve particular problems that you really only have to face if you're in a big system, like scaling issues, or how do you build your continuous integration pipelines to roll out certain servers, and again, in a hobbyist sense, you do it once or twice, it technically works. But if you've done it in a very suboptimal way, when you've got multiple developers pushing to the same server and then it rolling out continuously into Kubernetes clusters, you really notice it if it's really inefficient or something, or it takes forever to build, or so it's the less sexy, but more these are the things that you worry about if you want to adopt Rust into your infrastructure, right? That's
100%. And you've got and it's obviously, like you said, a scalability concern. You would obviously hope that your code base and everything around it kind of growing with it as the company or team or project grows. So not having these things in place obviously could kill off quite a few things, right? So it's quite important. Is there no, just on a separate note, is there no direct translations we can take from other languages that are already doing these kind of things? Maybe that's a stupid question, but does that question make sense? I.e., is there not unit testing case you could take from C++ or C or whatever, for instance, that are quite similar languages, or I don't know, Scala, because obviously that's still quite functional. Is there no way of taking any of that across, or is it literally no, we have to devise this for ourselves?
So that's a really good question, actually. You've stumbled onto some, it's quite a big conversation. There is and there isn't. So in terms of there's one concept, what we call as mocking, and that means that you put a wrapper around a certain object, and then you monitor every call that goes into that object, and you can also dictate what comes out. So what you'd mock is a database connection. You'd say, oh, what happens to my code if I get these rows back, or I don't get a connection back, or something like this, or I want to make sure that I get this sort of data passed to the database, when my code executes, if I put these kind of inputs in. With Rust, because it's got a very strong type checking system, you can't just create a mock and pass it into the function that you're testing, because Rust will refuse to compile. It'll say, well, I've expected this type and I've got a mock type, which is kind of that's the beauty of Rust. Rust is very safe. It's very strict in its type checking, right? But then it just makes it a bit more of a headache when you're trying to test. So then there's these things that you can do called traits. And then traits kind of append onto these objects or these structs. And then you can mock those with a with a thing called mockall, a third-party crate called mockall. So that means that you can create whatever trait, whatever struct you want, and then you attach your mock trait. So, for an example, you could have like a user trait, user struct, and then you could implement a trait called give damage and take damage in a game, and they have these certain function signatures. So then you can say this function accepts anything that has this trait, and then you can create a mock and pass that through via that. So you have to just think about it in a slightly different way. And there are some software engineers who, and you do see it with, again, it sounds like I'm just trash talking hobbyists. I'm not, I was a hobbyist myself, right? So
yeah, sure.
It's where they don't consider that. So when they have these functions, they accept just directly the struct instead of the trait. And it makes their code less flexible, but it also means it's really hard to test. It's really hard to mock and test, and because they're not, if it's just a casual thing that they're playing around with, maybe they don't thinking, oh, I have to do test-driven development and stuff like this, and they just never see it, and they grow this kind of like bad habit of they've got these functional games that they can build or something, but actually in a bigger system, they're designing their code that's really hard to unit test. Where this gets a bit more complicated is async code, because we don't know the size at compile time for an async future. So we have to put it on like the heap and stuff. So you don't really get async traits. Unless you put it on the heap, and you reduce the the performance. And that's coming out. Like Rust, the Rust engineers who are building them, the language are saying that they're going to implement it. So it's something that's coming on in the future. But that means that if you want async code, then it makes it even harder to test. You can still do it, but it's there, right? So, but yeah, that's particularly why the testing in Rust is slightly different. You have to slightly restructure the way in which you structure your code, right? You have to think about it in a different way. You have to think about it in terms of traits if you want to end up testing that function later on. Whereas in other things like, let's say, Python, you could just pass your object directly into the function. And because it's dynamically typed, you can then just pass a mock directly into that function, and Python doesn't care.
Yeah.
So that's the other thing. So again, this is why I think more material in like test-driven development in Rust is like super important, and once we get that community up and running, I think then the adoption is going to be much more aggressive.
That's good. It's so interesting that that's never been like, well, the language has not really needed that, I suppose, because of, like you said, all of its safety features. I suppose no one's really thought about the testing, and as the language grows and as we adopt it more and more, it's just interesting how that's kind of evolved, and now we are talking about these things, and that there are people out there that are really interested in it now, and not, I don't know, years ago, right? Just because it's not really needed to have been thought about up until now, as, I don't know, systems grow and projects grow. So cool. All right, well, we'll see what we can do there. We'll try and build something out. I don't know where, but we'll have a chat maybe off recording, and kind of see like where we can, I don't know, get some of these conversations happening and some of these things going, because obviously there's a need, and I'll be intrigued to see what people say to this, and you'll probably get bombarded with a load of messages and asking like, how do we go about doing it, which is quite interesting, but we'll figure something out.
Yeah, I mean it is something that's like the influencers don't really shout about, because I don't think it really gets much views, but like literally like that one comment on LinkedIn, and then like Discord engineer was like, oh, how are you doing it? We're doing some things, but and it's a bit like, I came from I did work in the NHS before I studied physics, became a software engineer. I was a nurse before, and the really boring stuff in the NHS, people always think like, oh, it's all CPR, and I worked in A&E, and actually the majority of stuff is like referral forms, and did you get the right like documentation to the right thing, or did you get the right scan? Have they got a wristband? That's crazy. It was probably like the best way you can like reduce errors is like putting the right wristband and make sure they have an allergies band if they have it. Right? And it's the same like in pretty much everything, right? I'm sure it's the same in recruiting. Like there's certain things like getting deals and that, but I guess like getting the people across the line, getting the paperwork filled out is probably like a big part of it.
It's the fundamentals, right? Like, and the foundations of it are so much more important than the flashy, like you're saying, the sexy stuff that everyone keeps talking about. Yeah, 100% right. I mean, I agree fundamentally with that. Yeah, we've got to make sure that the core stuff is there and it's done correctly before we can kind of look at, all the cool stuff on the other side. But hey,
so maybe that's the thing, right? A London community on test-driven development Rust or something, where we try and come up with standards and methods, and material like that would be pretty awesome.
That'd be pretty good, and maybe on site as well, like face-to-face discussions as opposed to just everything async, messaging to and fro. Although that documentation would also be quite helpful, just to have somewhere and to share. But yeah, having like a bit of a workshop or a group session where everyone talks about these things is pretty cool. I think I'm sure we'll get some traction there. Cool. All right. Well, thanks very much. I've just got a couple of questions on my side just to kind of wrap things up and get things going. Obviously, a big part for a lot of people watching this is kind of understanding, and you did kind of mention briefly where you went to learn in your beginnings, and a lot of it was probably trial by error and kind of giving it a go whilst lockdown was there. We're thank God outside of lockdown again, and we don't have to go through that again. So a lot of people kind of be juggling work responsibilities with trying to grow this out. But right now, these days, you've obviously got a really good understanding of things and you've grasped it and you get to work with it every day. But where do you go to learn new bits on Rust now? Where's your kind of go-to sites or documentations, or I don't know, where do you go to learn?
So I think like with Rust, because of the type system, the documentation is actually amazing. So you get like this auto documenting like system. So if you build a library and stuff, you can usually cargo create docs and it will just generate documents based on like all the type systems. It will read through and work out what's going on. So I think I'm now at the stage where, I mean, I still read books. So I'm currently reading Mario Boss's like Atomic Locks, O'Reilly book, and it's about basically how you build your own locks through atomic primitives and all this sort of stuff, which is pretty cool. But like it's get to the stage now where you just go directly to the docs of whatever like library you're doing, and you can just look at the source code, and because all the types are very similar, you say, oh, it returns this type, does this. You can kind of, even if they haven't like written their own comments behind it, you can kind of work out what's going on. And I find that's just so much quicker. Mm-hmm. And again, that's another advantage of Rust. Is because code is always just more concise. It's just a quicker way of doing things. So like if you look at, you must have heard of like Terraform, and stuff like this. So infrastructure as code, that's the same thing. So you could point and click on AWS to spin up your server, but actually infrastructure as code is just so much quicker because you version control it. You can just look at it and say, okay, it does this. Whereas if you're trying to document it, you'd have to do like a screencast or something like this. So the type system in Rust is really good in that sense. You just go to the raw docs. They all boil down to some essentials. So even if you look at like a mutex, it boils down to like an atomic bool, or whether you can access it or not. If you want to build a channel, you can have two mutexes either side and a queue. It all boils down to these core fundamentals, so you can just keep going down. So that's where I'm looking at now. It's just raw documentation for a lot of this.
Cool, fair enough, nice. And next question, other than your own, which of course we can recommend, what books have you been reading? So you mentioned that one on atomic locks. Anything else?
Yeah, I would say the online Rust book that's kind of free and available is a really good place to get started. That just covers like all the fundamentals. If you want to go even further, the O'Reilly just Rust book is pretty good. It'll explain why certain things are a certain way if you're that way inclined. But, you know, it depends what you want to use Rust for and how deep you want to go. So,
Cool.
but those two are pretty solid, yeah.
The classics, the staples. Nice. Just a slightly obscure question, and I asked Eugene this in the first episode as well. Let's say you were going to learn Rust again from scratch. Knowing what you know now and the journey that you've been on over the last couple of years, what would you do differently that might speed up the learning process, if anything, or what would you do fundamentally different that, on reflection, you maybe did poorly the first time around?
I mean, this is almost cliche, and I think every language says the same thing, like people in every language, but it's like trying not to run before I can walk, right? Because you learn a bit, you kind of like, oh, I can get something kind of running, and then you like try and build a web app or something like that, and it's just like actually take your time and focus on like really understanding the borrow checker, really understanding, you know, how memory is managed, you know, do the boring stuff first. My philosophy in life now is focus on the boring stuff. Hence, like, been telling you about testing and all this sort of thing, right? Because that's the stuff that really gets it done, you know. So yeah, I would do that, and then start to look at a particular area that you wanted to do, just one area. Again, like Python's very kind of like I think it's also quite bad for this as well, where you could theoretically do anything, right? You could build a web app, you could build a desktop app, you could just, you know, in Rust, you can build front end. And I often see with beginners, they kind of like, it gets slightly hard and then they jump to another kind of thing. And it's like, no, you just got to push through that and just kind of ace one area first, right?
Yeah.
And it's whatever area you want to be, right? Doesn't matter. As long as you just complete that kind of area. Right?
Sure. I always find that's the biggest pushback that I've had over the last couple of years of that. I don't know if it's a misconception or not of, oh, Rust is really difficult to learn and it'll take me ages. Uh, from what I understand, and you can correct me if I'm wrong, I think people give up on it quite quickly just because they keep getting told no a lot, right? And it doesn't work. Like we yeah, no, and people go, well, screw this, I'll go to something else where, you know, I can at least like get something out, even if it's potentially not kind of the right thing or it's not correctly written, and you'll probably have to go back to it in the future. Like, sorry, so that was probably like a two-parter question. One, is it a misconception that it takes a long time to learn? And B, like, am I right with my assessment of it or from what I've heard?
No, I think you are right. And it kind of gives you a way of like, it depends what type of developer you are, I guess, when it comes to learning Rust. So I have seen, and online comments are not like the whole world, right? So I appreciate that. But I have seen like experienced developers basically throw their toys out the pram because Rust forces good coding style. So let's say if we go back to Python, the classic example I always do is strings. So strings, we don't know the compile size because they all vary. It's not like an integer or something, like a 4-bit integer or an 8-bit integer or whatever. So with that, like when you add strings together, it has to reallocate memory, sweats under the hood. So if you go on Stack Overflow, you see Python developers going, oh, when I loop through an array of strings and I keep adding them to one string, it's super slow. Why is that? And it's like Python hasn't defied the laws of computer science. It's just that Python sweats under the hood and just keeps reallocating the memory on every iteration. And that's why it's so slow. Whereas Rust is going to complain to your face that that's what you're doing. You have to actively say, I'm going to clone this, or I'm going to move this, or something like this. So they want to do it, you know, that way, and they love it. But like developers are a whole bunch of people. You get some really smart developers, you get some really lazy developers, you get some really motivated developers. And I think Rust, because it forces you to acknowledge these things, does kind of smack you in the face. And there are people, some, not all obviously, who just don't want to do it. So like they try Rust. I've seen this. There was the one that really stuck in my head. It was a PHP developer, and he obviously tried learning Rust, and he was like on LinkedIn, I'm trying Rust out. Rust is great, you know. And then like a month later, he's like slagging off Rust, going like, "That's terrible." You know, PHP. He literally said this. I'm not exaggerating. He's like, PHP has all the best stuff that Rust has to offer anyway, which is kind of insane. Like, does you know, PHP, like Rust. I'm not saying that PHP is terrible, but they're different languages, right? You
Sure.
don't have like Rust has memory safe and doesn't have a garbage collection. PHP has a garbage collection. It's just factually incorrect. But what he'd obviously done is like Rust just kept smacking him in the face and saying, all those bad habits you've done with a scripting language, I'm not going to let you do them. And he just couldn't get over that. So instead, he threw his toys out the pram and said, like, you know, Rust is terrible and all this sort of thing. Now, there's legitimate criticism of Rust. Not everyone's going to love it, but you are right in terms of like there is a certain group who of developers who just form bad habits in other languages, and Rust is kind of like a bouncer. It's just not going to allow those things
Sure.
into its coding style with its borrow checker. So,
and as long as you can break through that, hopefully things change for you. You know, I think that's just the main thing that I've heard and learned. And yeah, once you break through, it's all up from there. Hopefully. I suppose my final question then, just to round everything off, if I may, is like, what's your hot take? What do you kind of think or envision? Where do you see Rust heading in the next couple of years? That might be industry, that might be, I don't know, the language as a whole, or I don't know. What's your kind of take on it? Where do you see it heading in the next couple of years?
Well, I'm a bit biased, so let's use to take it with a pinch of salt.
Sure.
I've written books in it, so I'm obviously going to say it's amazing.
Uh-huh.
But I stick by this. I honestly think so. The Rust is the language version of Docker. So you know about Docker, right? And
Mm-hmm.
that sort of stuff. So before Docker, you used to have like a deployment team, you know, a production team or something. You used to have a development team, and there was this saying, "Oh, it works on my computer, but it doesn't, you know, work on the system or whatever." And what Docker enabled, it enabled this revolution where your developer could also consider deployment, and they could test the deployment on their laptop, and then they could package it and they could chuck it onto a cluster or something like this, right? And it broke down the barrier of like, now there's still, you know, DevOps engineers are still super skilled, and you know, it doesn't mean that just because you can run a Docker container you can replace a DevOps engineer, but it broke down the wall where your average developer was starting to think about deployment and actually starting to wrap their own things and could do simple deployments with this if they wanted to, right?
Mm-hmm.
And what it enabled was, instead of those DevOps engineers like fighting all these build logs and trying to get their server running the way they liked it and all this sort of stuff, they focused more on like orchestration and scaling and, you know, like auto scaling and Kubernetes pods and all this. So it pushed everything up. Like it was a rising tide. Everyone benefited from this. I think Rust is like that with systems programming. So, you know, we've had it where we've had to build our own custom caches, and the Rust compiler has stopped me doing some really stupid stuff, like some memory unsafe things with like mutexes and stuff like that. And what we've been able to do is build a really performant like custom caches for particular problems that we solve. So like Docker, where it enabled the developer to just start handling around and safely like packaging servers and stuff. Rust is going to enable developers to start just diving into a systems language when they want to safely, and they can start to build their own cache. They can start to build their own driver or something like this. People are building OSs in Rust, but it's all memory safe, right? This is a map, so I honestly think it's like the next revolution that's going to happen, where you'll have like you can have it where someone will build like a Python server or whatever, you know, and then like they may need like a sidecar custom caching mechanism just to deal with that problem, and they can reach to Rust and use Python binding stuff. You know, whereas before they'd have to dive into C or C++. There's all these like potential memory safety errors, you know, and it was a much bigger hurdle. They could do it if they dedicated enough time, just like a developer could, if they dedicated enough time, deploy their own stuff on a raw server. But there's more brittle moving parts.
Yeah.
You know what I mean? So that's it. It tears down the wall for developers and systems languages. I think just like Docker tore down the wall between developers and deployment.
Interesting. Okay, well, let's see. I mean, we've already seen plenty of that happening already over the last, certainly over the last 2 years. We've seen those kind of changes and transitions happening. I mean, long may it continue. I'm biased as well, obviously, but let that kind of push on. But yeah, interesting take. Well, look, unless you've got any sort of closing comments for yourself, I don't know if you want to say anything, but I thank you so much for your time. Appreciate chatting through this. We'll obviously talk a bit off camera about how do we kind of build and create a bit of a community around the testing piece. And as boring as that may seem, as you say, actually fundamentally that's pretty damn important for us as a community moving forward. I appreciate your hot takes. I'll obviously put the links to your books and whatnot in the description of the video so people can have a look there. And hopefully you don't mind people maybe reaching out to you down the line and asking for your takes on a few different things. And we just kind of start, yeah, building that side of our community as well. But I appreciate your time. Thanks so much, Max.
Thank you for your time as well. I really appreciate your podcast.
Thank you.